And hello, welcome to this video of OPCUA with C#. Now, before I start, I just want to give credit to this man here, Kazai, from Industry 4.0 TV. Yeah, he's a very smart guy. He's an expert OPCUA as far as I know. I am still sort of on this learning journey, and as I learn, I compile together what's useful quickly, and yeah, I'll do it I'll show you what I've got. Okay, so yeah, he's laid out a very good series which I highly recommend, though he does use Visual Studio, which is not the way I'm using. I'm using the Vim way, the Linux way. He's using Visual Studio's Windows Forms, the very Windows way of doing things. So yeah, there might be some little bit of challenge that I foresee coming up if you want to learn OPCUA doing the Linux way, but I mean, we'll stick with that. Yeah, because Linux, running servers on Linux is a very good practice, and also in a sense, yeah, if you want to run things quickly and stuff, you kind of want to deal with Raspberry Pis and all that. All these are Linux systems. And even you want to deal with lightweight systems, Linux is better. Now, of course, you can use Windows servers as well, but yeah, Linux has way more experience with open source, dealing with open source software and stuff, which is just my preference, and it's way easier to access. Okay, and yeah, so now without further ado, let's pick up like where we left off. Okay, so where we left off was right around here. You see on the right, I have my OPCUA server running, or at least not my OPCUA server, the reference OPCUA server running along with some methods and yeah, pardon me, some methods which we were talking about, asynchronous methods. Now I've actually played around with this server called the test server 2, which I'm experimenting with behind the scenes. And once I'm done, I kind of just show you what I've done, if it's useful, and that's the style of which I'm doing these videos. So the learning pace will be slow. It will be somewhat more digestible rather than just throwing all the information at you. If you want to have information thrown at you and it's very compact, concise, do visit Kudzai, I think. I hope I pronounced your name correctly. Yeah, so if I'm pronouncing wrong, just let me know. But yeah, yeah, he's way more well informed and specialized in this area, so you might want to check him out. Yeah, so what I'm having now, what you're seeing on the right, is just me with my my own test server, which I just modified the code here just to play around and tinker around, get new asynchronous tasks working. And I've also connected it to the client right here, the console reference client, and I had to make a few tweaks just to get it working. So without further ado, let me shut down this client, and let me go to shut down this server as well, and I'll start us off with the test server. So last time we left off. Yep, so last time we just left off, I had this test server. So I'm going to open up the UA server part of the test server, and I'm going to cd and I'll go to test server, and over here I'll do dotnet watch run with framework net 6.0. Okay, so this is what I'm gonna do. Alright, so this is the test server which we had the last time. It will take some time to build and stuff, but this is what we have here. Okay, the last time I just did basically on the async status thread. Yeah, status thread async here is a task. A task is a method that can be, I think, run asynchronously. Okay, so on this thing, I just printed the hello 123 and server started, press Ctrl+C to exit. Now, what I notice here, of course, yes, I can exit if I want to, but you see, the more I keep printing these messages, the harder it is for me to see what URI or URL I need to connect to the server, because the server information is right here. Okay, the server information is right here, and the more printout I get, the more obscured that server URI or URL, I think it's a URI, the server address, the more obscure the server address becomes. Now, second thing, I also don't need the Ctrl+C to display every like 2 seconds. It's getting a little bit annoying, as you can, if you keep staring at this all day, it's really unnecessary information. So how can we do this? All right, so I'm going to just play tinker around and show at least how to add asynchronous tasks and run it within this reference server. So everything within this while loop I can delete. Okay, I'm going to use the vim thing to delete di bracket. Okay, so here I have a status thread async, and I will probably get thrown an error because this is a asynchronous task. So the asynchronous, it's of the same name as this status thread async, so I'll need to write something like it's not playing, it's not doing the thread status. Maybe I can just call it important info async. Okay, I'll just call it important info async, and right now it's not running any code. Okay, right now it's not running any code, and it's complaining that I don't have an await operator. So I'm just going to put a await task delay. So instead of 2.5 seconds, maybe I'll put 25 seconds. Yeah, 25 seconds. That's somewhat longer. So this async task will have an await. So every time it will just have this await. At least there's a delay for it to go, so that it won't keep running continuously in the background. And of course, the compiler won't even let us compile the thing. All right. So what do I want here? I want this line right here saying server started. Please press Ctrl+C to exit. I don't want this output write line anymore. Okay, and at least this will help us to decrease the frequency of things. Now, okay, now it's complaining now that output doesn't exist in current context, which is right here. Let me check whether my Omni Sharp is working. Sharp status. Yeah, it's been running. Okay, for some reasons, like not doing the lint. It's not showing the error. Okay, so I'm going to cut this and I'll paste it here. Yeah, that's better. So yes, now it should work. Every 25 seconds, you'll have this Ctrl+C exit thingy. Now, what happens if I want to get these two pieces of code here? Okay, this is information that displays what URI or URL I'm supposed to be connected to, and this is where usually we have our start async or something like that. So let's go to the top. Start async. Okay, the start async is right here. Right, so start async is this function here which constructs everything. It will do a try catch kind of a loop, as you can see. VI, yeah, the try catch loop is here. Okay, and it will start making a new server, and it will start the server and okay, according to the commands here, save the state. Here is the important part where it actually prints the endpoint info. Now, endpoints are usually the place where we start connecting things. So I want this endpoint info to be printed again. Okay, I want this endpoint to be printed again, maybe every 25 seconds, along with the thing. So let me go down and I'll put it here. And you might be asking, you know, why isn't the thing printing anything, right? It's simply because we have defined this method. Okay, we have defined this method, or the correct term is that we have defined this asynchronous task, but we have not started running the task yet. So we'll need to start running the task. Okay, so I'll call this task private task. What is this task called? Maybe I'll call this m important info. Okay, m important info. I'm just following the convention of m over here. And I'll just say this is important info I need to print every few seconds. So yeah, and then now what happens? It says a task is defined but it's never used. Okay, m important info is never used. So what we need to do now is to start running the task. How do we run the task? Okay, good thing there's a template for us here to just copy and paste, and that makes it a lot easier. Where is the start async? Okay, vim grep start async. Start async. Okay. One more time, vim grep start async %, and here we are, start async. Okay, so here is how tasks are supposed to be run. So I mean, I have very little experience with asynchronous programming, so all this is nice to have. So yeah, I'm just do a copy and paste. Let's start the important info thread. Okay, because we are running in parallel, I think threads mean it's running in parallel, at least to some extent. Then I need to have my m important info. Okay, m important info, and it will be running the important info async. So this is the task that I'm running. Okay, this is the task that I'm running here. And now the task is running. Every 25 seconds, this important info will kind of be there. Okay, OPC TCP arch SSD and desktop. That's my computer name or something. Yeah, it will run, and it won't keep displaying itself over and over again because it will get irritating after a while. So let's wait for a while. See, now after like 25 seconds, you can see 22 it's 22 seconds here, and then it's 47 seconds here. You do the math, it's actually 25 seconds. So yeah, every 25 seconds the things will actually print out. Okay, the things will actually print out. And if I don't want the information to be printed in the output, then what I can do is I will use this console output write line instead. So instead of using this m output object, I'll just use the normal output, which is the console.out way, and then this OPC info will not be printed here. Rather, it will be printed more like inside as a text. Okay, so just wait another 25 seconds and you will see this thing come out. Okay, and the thing is like auto reloading because I use .NET Watch, so that's very convenient. Okay, and every 25 seconds you should be able to see this. Alright, so I will just do other stuff and now I'll come back and check on the status of this. Okay, so we have covered how to do at least add some important tasks here. And of course the next thing we want, yes, take a look. We have our results now. Okay, but anyway, the next thing we want is to be able to connect it to the client, at least on a basic level. Now, the thing just to speed things up, okay, I mean, I'm just hoping to get us started and, you know, not deal with too many like security details, because this is just a test after all. Okay, so what I'm going to do is I'm just going to start running my client, and what I changed just now was this thing called autoaccept. Okay, from false to true. But why am I doing false to true? You will see very shortly. Okay, I will do .NET watch run framework net 6.0. Okay, that's the command, because the normal command is .NET watch run, but they'll complain that I'm not specifying a what do you call it, framework. Now, what code I'm running? I'm actually running the console reference client with barely any modifications. Okay, so what is the reference client saying? Okay, it says untrusted certificate is rejected. Create session error, certificate is not trusted. Okay, and it is just not connecting. Okay, how do we actually get the server to talk to the client if these certificates are not accepted? So to help us with this certificate exception issue, well, I looked at this part. It says auto accept certificates. So auto accept certificates for testing only. All right, they actually help to check for the certificates. Okay, they will actually help to check for the certificates. And this is what is actually causing these untrusted connections to manifest themselves as errors. So we are just getting started with this. I mean, I'm just getting started with this, and I don't want to deal with certificates security just yet. I just want the server to talk to the client, and I want to have a nice sandbox. So what do? I change this auto accept option to true. Okay, I change this auto accept option to true, and of course you can actually run this server within the command line as a program. But yeah, there you go. Look at this. Now you see that it's actually connected, and it's actually doing some random things that I don't really have an idea. But well, it's actually talking about these things called nodes, arrays, display names, node class, which again may be very confusing at first. What's a node? And you will see the word nodes coming up over and over again in OPCUA. And then yeah, what's actually going on? Okay, so I mean, the auto accepting, we can turn it to true and it will accept this side. Okay, if I change this to false, and I go to my server side, and let's try the auto connect equals to true. Let's see what happens. Okay, and now I'm going to do .NET watch run again. Okay, let's see whether it connects as well, or will we get the same errors. Okay, it says again the certificate is not trusted. So the only thing that we need to really deal with is to make sure the auto accept in the client is true. Once the auto accept in the client is true, we should be able to run our server as a sandbox, and we can just forget about certificates because doing too many things at one go is complicated. Okay, next thing, of course, you'll be wondering is what are nodes? Okay, what are nodes? Okay, so usually when the short story as far as I know is, yeah, when the server wants to talk to the client, okay, how does information pass from the server to the client? Okay, there is a standardized way of transferring information. You don't just pass a string or double or whatever. There's a proper OPC way to do it. That's why OPCUA is talking about a protocol or a standardized way for servers and clients to talk to each other regardless of languages, and they all have to conform to a certain set of standards so that your components can talk to each other without worrying about different doubles or strings or whatever, different formats of data. So everyone has to talk the same language, and that language is OPCUA, so to speak. Okay, and in object-oriented programming, or at least most programs we have the concept of data. We have strings. Okay, we have strings, we have objects, we have booleans. So we have strings here, like passwords are strings, log files are strings. This timeout number here is an integer. We also have booleans. I don't know whether we have doubles. I don't even see doubles here. Okay, vim grep double. Okay, no match, no nothing. Okay, yeah, so there are no doubles or anything here, but you can see that over here there are various variables we can use: strings, doubles, floats, or string floats and integers. If there are floats, there are definitely double precision numbers there. It has to be there. Okay, so that's normal. Okay, but at least from the right hand side, we actually see the string floats and double things being passed over from one side to the other. Okay. However, OPCUA is more than just about strings and doubles. You actually want to pass maybe properties, you want to pass methods, you want to pass variables, you even want to pass classes over the OPCUA. So yeah, so maybe you want to pass some calculation methods, you want to have methods to start the server, start something within yeah, if you are remote controlling, let's say a pump, you want to start it up. Okay, where do all these how are all these things being passed over on the OPCUA server? Okay, they're passed over on these things known as nodes. Okay, every time you see the nodes thing here, nodes is the smallest, like the most basic unit of data within OPCUA. So you can have node classes, node objects, node methods, and of course namespaces are also within the OPCUA server, the concept of namespaces. So remember the hierarchy, we have methods and variables. Okay, we have methods right here, like the main method for this class. Or let me go to another yeah, UA client.cs. Yeah, so we have constructors, we have dispose methods, integers like this. Okay, and also over here we also have a session lifetime which we can change. That's why it's like disconnecting every 30 seconds. Okay, auto accept untrusted certificate is false. This is a property which we have to set to true. We have connect async methods. So all these, if you want to pass them from one client to another server, or server to client, or whatever, you will need to format it in a proper way known as nodes. So that's basically what the idea of nodes are about. And again, this gentleman here has Kazai, I hope I pronounced your name right again. He has given a very good primer of what that information model and what nodes look like. Okay, this is covered under OPCUA information model. So I will not cover what he's already covered, but I will just provide a link in the description. Maybe I'll paraphrase some of what he says if I need to, but yeah, basically the idea is how data is being transferred from one client to a server, regardless of language, is that everyone goes by a common OPCUA, so-called, well, in this video, information model. He calls it information model. So since this language is being used throughout all the OPCUA servers and clients, we can see that this is a very important concept to know. It's one of the most basic. So yeah, we'll probably visit that in coming videos. How do we deal with nodes? And of course, here's also made a very good video of how to create this information model, i.e. all these nodes, on the OPCUA server using .NET. Okay, he's using Visual Studio. I will not use Visual Studio. So my flavor of video will be very different from his, and I'll probably be doing it a lot slower. Since Visual Studio has a lot of IntelliSense and stuff, so a lot of auto completions, which I don't exactly I don't exactly use here. I really like my Vim setup. So and Vim is more minimalistic, and It allows me to SSH into other servers, other computers very easily to set up what I need to. In fact, this is what you're seeing now is me SSHing into another computer. But that can be very easily done with Vim, not as easily done with Visual Studio or some other things. So I'm taking full advantage of it. Yeah. So yeah, I think that's it. We have a plan forward. Okay, and the plan is to see how to make these custom node classes and talk about them in coming up videos. And just want to again share the links of these videos. And one more important one would be the OPC model design GitHub. OPC UA model design model compiler. Yeah, OPC UA model compiler. So this is the GitHub. GitHub thing that actually you need to do. So I'll leave this in the description. He's actually talked about it, and I'm guessing at some point in time we might have to touch it, or at least find an alternative to this, because this is very important. Okay, why? We'll find out. Okay, so see you later. Bye bye.